Welcome to this episode of the AEC Engineering and Technology Podcast, a podcast dedicated to helping engineering professionals find technology that fits their needs. In this episode, I'll be talking with Dimitrios, CEO and founder of Deep Excavation LLC, about his journey of creating civil engineering software, the role of engineers in shaping the future of our cities and infrastructure, and how his software is helping them to become more successful in their projects and endeavors. Okay, let's jump into today's episode.
Before we go on here, I'd like to recognize our sponsor for this episode, Tensar International.
Check out Tensar Plus, the award-winning design software for construction professionals to design with geosynthetics and calculate their value on projects. Tensar Plus is simple to use with a powerful engineering system at its core. Whether you're designing a crane pad or need to build a temporary road over muck, the cost, time, and carbon savings can be calculated, making comparison with alternatives simple. Whatever you're working on, Tensar Plus is your toolbox for success.
Dimitrios, welcome.
Hi, thanks for having me over.
Absolutely. And thank you for taking some time to join us on the show today.
My pleasure.
So we'll kind of jump right in, Dimitrios. So could you give us a little bit of insight into your background and kind of what you're doing on a day-to-day basis?
Sure. So as a young engineer, I wanted to go into aerospace and become an aeronautical engineer for NASA. But at some point, I made the 180-degree change, and I switched from deep space to deep excavations. Mm-hmm. So now, instead of going to the galaxies, we're going towards the center of the Earth, quote unquote. My background is that I was trained as a civil engineer, specializing in geotechnical engineering. I got my master's from UMass in Lowell, and my bachelor's and my master's from MIT in 2000, specializing in deep excavations. And then I joined a firm in New York. We worked on the World Trade Center recovery efforts from the bathtub. Some of the redesigns there were my own. And I had developed a passion for deep excavations through my graduate studies. And at some point, I tried to impress the old bosses in my company, wrote a software. I thought they would be interested. But eventually, I created my own business, and we're going to talk about that. And right now, I'm managing, I founded Deep Excavation LLC. I'm managing it. We have a number of employees, and we're helping people solve challenging problems that we're going to talk about.
Awesome. So now let's kind of shift over to deep excavation on the software side here, right? So it just kind of happens, right? Because you now have a pretty successful business, right? A software used by 1,000 engineers worldwide, but it started from somewhere, right? So how did it come? How did it come from basically nothing, right? And could you tell us a little bit more about how you got there?
That's a very interesting story. So first of all, I was writing the software just to simplify my problems as an engineer, because in 2001, 2000, I realized that it was taking a lot of time to do all these calculations by hand. It will take me like a week to run one design section, and then there will be changes. It will take another week. And I thought that was a very inefficient process. So I started writing the software, and eventually at some point I realized that that was my calling, to develop the business. And I sold my house in Astoria in New York, which, for those of you that know New York, it's the Greek-occupied section of New York City. Put all my things that was 2006, put all my things in a car, went to a convention, a Geo Congress, and tried to sell my software. I said, okay, look, I was younger at the time. I was like 30 years old. I said, if the software is going to work out, fine. If it doesn't, I can always find a job. So I packed everything on my car, went to a conference, started making sales. I didn't have that many high expectations back then, but at some point, this thing got traction. I got the validation that I needed, that the industry needed this type of solution. And eventually, the toughest thing was like adding the first and the second employee of the company, and then transitioning from not doing everything to like providing the vision of the company. And getting that feedback from people on what they need, the challenges. So it's basically, it's not that we come out with our own ideas, but we try and get the needs of the engineers that are using our solutions and tailor and address their needs for them to be more successful. So we're seeing our success coming from having our contractor and engineering clients be successful in their own lives and in their professions.
Yeah, and that's right, that kind of either minimum viable product that you start with to make sure that there's an actual need in the market, right? But it sounds like you got there pretty quickly, but could you talk in a little bit? Go ahead.
It wasn't that quick. I'm like, it was 2006, right? The real market traction we started getting in 2010. So it took like 4 years. And you have to recall that 2006 to 2008 or 2009 weren't the best years in construction after the market crash. So it was a challenging trip to convince a very conservative industry to change and adopt something new. Because the engineering and civil engineering, and especially the geotechnical community dealing with soils in the underground, is a very risky business. And for those reasons, the industry tends to be very conservative into adopting new solutions.
Which we see a lot and is echoed by a lot of our guests. But Dimitrios, could you talk about that time period, like 06 to 2010, and some of the specific challenges you faced in taking this idea from conception to traction within the industry?
So the first thing obviously is like, you come back with a minimum viable product, no matter what the market conditions are, and it's in your mind that you've done a great job, but then you crash with the market reality and what people actually need. So you have to reiterate a couple of times. Now, on the other hand, if people didn't have a project or didn't have a client and the construction was frozen, you don't operate a software firm out in the vacuum. You operate in the real world where there's construction demands. Now, there's always going to be some construction demands from natural disasters happen, but you cannot build a business out of that. So we're all integrated into the economy one way or another, at least in our levels, and not the levels that pay little to no taxes in tax havens, right? So because of that, all right, there has to be demand. If the construction industry is frozen, you can't sell engineering software. Simple as that. But that also gave us the opportunity to fine tune and improve our solutions. Like we went from the first iteration of the software, I recall, in 2006 to the 2008 version. Then we underwent significant improvements in 2010, and every year we're trying to beat ourselves and be more challenging, disrupt ourselves if we can before our competition does.
Yeah, and speaking of which, so could you talk more specifically about what Deep Excavations does and kind of the software itself, who's using it, and kind of your target audience?
Absolutely. So our software helps engineers and contractors design deep excavations, tunnels, foundation works, and anything that has to deal with the underground in terms of gravity walls, retaining structures, and so on. And the nice thing about it is that it's, I believe, one of the only softwares, programs, and solutions that essentially brings in the technical expertise and the details of what the technical construction would look like in terms of a structure, with the knowledge of the soils, because there's a lot of uncertainty. Then we couple that with a component which has knowledge of the design codes. And this could be design codes in the United States, in Australia, in China, in Europe as well, even in India. And then we give the ability to help our clients solve from small projects, and then even being able to model an entire subway line with an entire city and do that relatively quickly and come back with estimates of construction cost, construction schedules, and so on. And to top on that, our little pet toy project is that you can visualize all of this in augmented reality using HoloLens glasses.
Which is amazing, right? Because imagine, and I'm just thinking, right, and using AR and walking through
Exactly.
let's just say a whole new, let's say, Dallas Metro, right, got this huge new underground subway system, and you could walk through the entire thing. And
Before you build it, and you can see conflicts, you can visualize the project. But the essential part is not only you visualizing, us visualizing it as engineers. We have to be able to communicate what the project would potentially look like to the involved parties and the owners. So imagine you could take AR and take the subway and put it in the actual dimensions in the actual location and see potentially what it would look like.
Which is becoming huge in our industry, right? Because it's one thing to have a set of construction documents that UI and a contractor can understand, right? Mm-hmm. But your owner needs something maybe a little more simple and visual, right? So could you talk a little bit about that?
Absolutely. So owners, all right, and project owners don't understand the technical issues. What they understand is what they can see, what it would look like, how they can communicate that value to their constituents if we're talking about a city or a state. And they understand the impact on the pocket and schedule, especially on large infrastructure projects that tend to be severely underestimated in costs most of the times. And there's all this cost overruns, the schedule overruns. That's what they understand. And the visualization part is important because they don't necessarily have the technical background. And I think our industry needs to do a better job at getting to that level. And we're trying to, okay, so we're making progress, but we don't have the funding, say, of a Microsoft.
Exactly, because in let's just call it right what it is. It's essentially marketing, right? Is sometimes a little bit different because it's maybe what the outcome of the project could be, but not necessarily what it looks like. Which we're definitely seeing trends there, trying to make owners better educated, right? And I'm sure you've seen, right? Like you can lay out, the floor plan in 2D for an owner, and then have the BIM model kind of pop up to show them what their finished space could look like.
Yes, exactly. And I'm not the first one to say that, but our industry has traditionally been preparing to conceptualizing a three-dimensional problem in two-dimensional drawings to be built in 3 dimensions.
That's definitely true, and you bring up a good point because we start with, right, like you said, the problem in 3D, shift back to 2, and then it's in 3D. So it's like, wait, why did we have to go back to that 2D step?
It really comes back to being like a legal document, because your construction drawings are essentially a legal document, and you cannot necessarily create a B model as a legal document. And given that here in the US, we're I think we have the greatest density of lawyers per square footage. So that I guess justifies why everyone still has to do 2D drawings.
That, and I think, right, everybody in the construction industry understands 2D drawings, but if you started, let's just say you started building off 3D models, right? And that became a standard. There would have to be some learning curve, because you can't just expect people to pick up a tablet and go.
But what will happen is once, I think sometime in the future, I don't know if that's 20 or 30, 50 years or 100, you're going to have the 3D models, and the construction robots are going to build directly off the 3D model.
It's amazing. And,
in fact, right, with the printed houses, that's already happening.
So let's shift a little bit away, not necessarily away from the technology, but to the industry side, and we'll kind of move up the ranks here. And I'm curious to get your thoughts on each individual. So let's start with the younger engineers, right? How are they using your software, right? And what general advice would you be giving to those early career individuals?
So if we start with the young engineers, all right, first of all, dealing with the underground is a very risky business. You can't just run a software, be impressed by the colors, and have no real expectations of the solution that you want to find, your anticipated results, and just go out and build up something just because the software told you that's the right answer. So for younger engineers, they definitely need that feedback. And you also need to build up a strong theoretical and practical background. So you need some sort of supervision, and the system of supervision with the EIT system here in the US, I think, works to some extent well and serves the greater good for that reason. Now, our younger engineers, because they've been used right now to using so much computer, they get very easily impressed by nicely looking contours, gradients, and if the finite element analysis shows that it is correct, it looks beautiful, okay, that's it. There's no questions asked. And in fact, that's a great danger, because if you just solely rely on a computer output which just looks beautiful, you can actually miss a lot of significant things that can have a detrimental impact on your construction schedule if you have a collapse. And what our software tries to do to some extent, all right, is that it tries to guide the engineer to a more rational design process, where you have to go through the traditional approaches before you utilize any advanced methods. It will run structural checks. And in fact, many younger engineers said, we find this amazing software, and we have actually learned from the software. That's the more important thing, is that they've learned. And then the other thing is that we stand by our customers with top-notch expert technical support, helping them understand what are the differences and implications between the different methods. Ultimately, they have to carry the responsibility for what they design. But for me, my greatest advice to younger engineers is to learn the principles of engineering very well, build on experience, and steadily become better every single day at what they do. If you build up one brick at a day of expertise, eventually you have a wall.
And we say it all the time, right? Whether it's technology in general, software, artificial intelligence, right? You got to have some way to verify the output, or you're just essentially a monkey in front of a keyboard, right? And
exactly.
And that's really important. Everybody in the audience, you have to figure out ways to verify what a computer is telling you. Like Dimitrios said, whether that comes through experience and seeing how things are constructed in the field, right? Sitting down with engineers more senior than you to kind of get a feel. You really have to be careful there, or it can be a real problem.
Yep, I totally agree with that. All right, now a software can guide you up to a certain extent, but clients hire engineers to bring solutions to problems. They don't hire them to produce good images or good-looking software. So if you produce something which is unsafe, you're doing the client a disservice. If you waste your time, you're doing your client a disservice. So we have to utilize as engineers whatever tools we have, which are always evolving, but at the same time, we have to base this on experience and expertise and good knowledge of principles.
Absolutely. So Dimitrios, and let's kind of move one level up from those younger engineers and talk about maybe more of the mid to senior level and those project managers. How are they, in your mind, using the software, and kind of how does your answer to the last question change, knowing that we're talking about a different group?
On the mid-manager levels, usually some of them will run our software, others will basically have their younger engineers. Depending on the level of expertise, all right, they will look at what their younger engineers do, the solution that comes out, and they will say, yes, that looks fine. But basically, the software will enable their firm to deliver greater value at less time. Or even if you use the same time, you can investigate more alternatives and provide a more complete solution. And the big argument that we're trying to make in the industry is we propose to the industry to not charge by the hour, but charge by the value of what we bring. Like when somebody asks me, what is your hourly rate? I say, I don't have one. Tell me what you want to solve, and I'll give you a lump sum price. Because something that takes someone a week to do, with the level of expertise that we have developed internally in our company, might take me only half an hour.
Mm-hmm.
But that is a valuable project. I can't say to someone, yes, it took me only half an hour. People will not say, but I'm paying you so much money for half an hour. Yes, but for this half an hour, I had to spend 23 years of experience plus 7 years of graduate studies and so on. And every day we study that because we know that, and that's our expertise level. So I can't just be paid for half an hour of quote unquote work. So, and the big question in my mind is that we propose that the industry shifts away from hourly rates and charges by the value, because eventually technologies like ChatGPT will also transfer to the engineering field, and you might be able to produce those solutions in 5 minutes. Are you still going to charge for the 5 minutes of work that ChatGPT did? No, you can't charge that because there's liability. You have to review the results, you have to understand them. So you have to charge increasingly in the near future based on the value.
I've had this conversation before, and my opinion is, right, the billable hour disincentivizes innovation. And even throughout my career, I've been told, hey, you may have a better way of doing things, but we still need to bill the client X, right, to be able to have this considered to be a successful project, which was always strange to me because it's a win-win. You can end up doing better for the client at the same or less cost. So I'm right there with you, but I'm curious to see what sort of timeline do you think we're on where that lump sum becomes more common than an hourly rate?
Well, I would correlate that with how generative AI infiltrates into the engineering profession. So I think we have a 10 to 30 year time horizon.
Mm-hmm.
So already, you see OpenAI coming in. I'll say 10 years right now. I once did a presentation about 7 years ago where instead of writing the commands, I talked to Deep X of 2035. We can actually talk to the software right now. It can do things, but not to that level. And the software basically goes through the iterations. I go back for coffee and I come back, and the software has come up with 10,000 combinations. And I'm looking at it, says these are the most relevant that I think are more applicable. So it's like talking to Jarvis or talking to the Star Trek computer. Imagine that, and you have a engineering solution. Will you still charge for 2 hours of work? I don't think so.
Well, think about why, right, that human to human connection is so valued in engineering, because when you're a senior engineer and you're talking to either your mid-level PM or your young engineer, right, because you can give them verbal instructions and it doesn't take you very long to do, and then they take those verbal instructions and turn it into work product, right? Now, like you're saying, if you can start getting software to do that for you, the value of that technology really increases.
Right, but you still have to be a human on top, because I don't think any AI solution will be able to take the professional liability that an engineer. So you still have to be on top, but you can't charge 2 hours for that.
And
then you have your own things, your own experience. You say yes, no. There's things that will go wrong. You might have to make adjustments. You have to know how to make the adjustments and not solely rely on AI. But that day is going to come when you won't be able to charge per hour, because your clients know that it doesn't take an hour to do it.
And we've had this discussion on the show a few times too, where that competent engineer in the seat isn't getting replaced. You mentioned for liability, right? But just like AI, right? It's like, lo and behold, we humans too have some intelligence, right? We have experience, we have nuance. Yes. That's not always captured.
So I don't think we're talking about the replacements of engineers, but we have to find ways in the near future to incorporate AI more creatively, and so that we're more productive, minimize risks, and deliver value, and not get replaced.
Beautifully said.
if you cannot think outside the box, if you don't know your principles, you will get replaced, unfortunately, by the new technology.
And so, let's get back a little bit more to the present, right? This is all like super exciting, but I'm interested to hear too. Can you give some specific examples of how deep excavations is being used today, in kind of real life projects?
Absolutely. So if you're out in New York, the Jacobs Conference Center, the excavations were designed by Deep X. Second Avenue Subway, some of the stations were designed with our software. Los Angeles Regional Connector, the subway stations, most of them were designed with our software. Numerous excavations, like for the Amazon buildings in Seattle, worldwide, like in subway stations in Turkey, Greece, even in London, Australia. Our software has been used there to design subway stations, commercial excavations, landslide stabilization projects, tunnels, and so on.
And it sounds like, so you've definitely got coverage here in the US. What about like worldwide? How far and what other countries are you seeing work?
I think the most exotic place that we've sold our software was New Caledonia, which is like an island north of Australia. I think it's under French jurisdiction. And I was trying to convince my wife to allow me to go and do a personal training there. But she was saying, no, Dimitrios, you can't go by yourself to New Caledonia. So, we have like clients everywhere, like South Africa, Australia, New Zealand, New Caledonia, Singapore, Japan, China, India, Turkey, Greece, Germany, Spain, France, England, Ireland, Canada, New Mexico, Argentina, Chile, Brazil. We're all over the place.
And how do you see, right, these clients all over the world shaping, right, cities, infrastructure over the next, 10, 15 plus years, right? Like what role does deep excavations play in helping your clients solve the world's problems to come?
So one of the things that we're working on a larger scale is how to better simulate on the early planning large subway projects. So that means forecasting demand, forecasting the costs, assessing the impact of the construction works when you're excavating on the existing infrastructure. And we're really passionate on that component, on delivering better solutions that allow engineers to more quickly evaluate large-scale projects. So on that part, if you say greater good, that's one. On the smaller part, by making excavation safer, we essentially save lives and infrastructure, because if you have excavation collapses, you can get significant project delays, as what happened in Singapore with the Nickel Highway in 2004. That was like almost a $200 million, like 3-year delay on a major infrastructure project. And people's lives were lost. So we're making the world safer from that perspective. But, there's like a whole wide range of benefits that come to society, from smaller to greater. And using our software helps engineers address those challenges.
Beautiful. So we've talked about, right, the big and these huge infrastructure projects. We've talked about, right, the future of deep excavations and maybe being able to give it verbal commands at some point. But what else haven't we talked about? Like what's next and what's on your radar for the company?
Well, our next part is, continuing to develop our solutions. I can't specifically say right now what solutions and how we see the future, because we want to shape the future before somebody else does. But obviously, if somebody follows up in the discussions, in today's discussion, they can figure out the next areas where we would work on. But the idea is that we want to continue supporting our clients and help them deliver safe, economical solutions at a quicker pace, and make them be able to charge more for their time. and not only by the time, but essentially by the value of what they bring.
Excellent. And Dimitrios, it's been a pleasure, having you on the show and getting to learn from you. But if our listeners want to connect with you, ask more questions, or hey, maybe they want to find out more about Deep Excavations, where can they find you?
So one place they can find me is on LinkedIn if they want to personally connect with me, under Dimitrios Konstantakos. Our website is deepexcavation.com. And if somebody wants to email me, it's Dimitrios@deepexcavation.com.
Excellent. And just like always, to the audience, in the show notes, you'll find those few items. So they'll be accessible there. And as we always make at the end of every episode, please reach out to us here at EMI if you need some help looking for, solutions through use of technology, right? Dimitrios is here to help. We just want to see the industry get better. But again, Dimitrios, a pleasure having you on, and thank you so much for joining us.
Nick, if I may add one thing for you listeners, because you are talking from the EMI, dealing with the underground and underground construction can be a very risky business, especially when you look at it from the management perspective. There's a lot of unknowns that can happen. And if somebody is managing a large infrastructure project, such as a subway, it's wise to invest in good quality soils information. This will pay dividends going forward. And even on smaller projects, if you don't have adequate soils information, a lot of things can happen wrong, and they can throw off both your budget and your schedule, of course.
Agreed. And if with that preliminary information, right? So I take it it's likely just another feature of what you guys are doing to incorporate the info as part of their designs.
Yes. Yes. So
beautiful.
We have such options, but I'm just talking just in general. Forget about software. On the management perspective, you have to know where you're placing your infrastructure, and if you don't invest properly in the soils information and getting the right data out of it and communicating that process as a dynamic process in your project, you are running greater risks.
Beautifully said, right? And that first principle, right? Just making sure you're doing your due diligence from the start, because it's going to set the tone of your entire project.
Yes. I just thought I added that because it's EMI and you're talking about management and like all these things.
Well placed and well said, Dimitrios. So again, thank you so much for joining us.
My pleasure. We'll be in touch, Nick.
Take care. Please remember, you can find the show notes for this episode at aectechpodcast.com. There, you will find a summary of key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, I wish you the best in all of your engineering and technology endeavors. Thank you.